right, so looking at problem number 1 of our review, a glass case in the shape of a regular or equilateral triangular prism has base with side 3 centimeters. So all 3 of these sides, even the one that's not labeled in the back, has a side of or length of 3 centimeters and a height of 12. So all 3 of these heights from B to E, E to F, and A to D are 12 centimeters. H is the midpoint of B to C. G in the back is the midpoint of A to B. And I on the top is the midpoint of E to F. The case is to enclose an art piece in the shape of a triangle attached at D, G, and I. So that's why that red triangle is there, that's the artwork that's supposed to be enclosed in this case. Part A, we're looking for the angle between DH and the base DEF. So between D to H, just that green dashed line that you can see in there, between that line and the base DEF on the top. So thinking about DEF, even though it's an entire base, we can create a triangle from or using DH with piece of that base. So if you notice, even they kind of help us out in this diagram that D to I is along that base on the top. And if I connect I to H, I'm going to form a right triangle. So let me bring that triangle out of the 3D figure. All right, so this is the triangle I'm looking at. The I to H and D to I will make a right angle or a 90-degree angle because it's a height that's meeting up with a base. So that'll meet at a right angle. So that's helpful to know. Also helpful to realize that I to H or H to I is the height, which is 12 centimeters. And we're looking for the angle between DH and that top plane. So we're looking for this angle at D. So now the question is, if I'm looking for that angle, I only have one side right now. So I need to figure out more pieces to this puzzle to figure out either D to I or D to H in order to use right triangle trig. So looking back at my 3D figure, if I'm trying to figure out, let's see, D to H is right in the middle of the prism. So that's not really going to help me, or I'm not going to be able to easily find it. But if I look at or pay attention to D to I cannot draw a straight line to save my life on there. I know that I is the midpoint of E to F. So that means if E to F is 3 centimeters, just like B to E, that means, let's say maybe this length is 1.5. And I also know that this length from D to F is also 3 centimeters, just like A to C is on the bottom. So let me bring that triangle out. All right, so looking at the triangle DIF, we again know that F to I is 1.5 because it's the midpoint, because I is the midpoint. We know D to F is 3. And I also know that if I is the midpoint and it connects to another vertex of the triangle on the top, that means this is going to meet at a 90-degree angle. So it's relying a lot on geometry in this very first problem. But the good news is that now I know 2 of the 3 sides of this triangle. And if you notice, this side that I'm about to find is the same as this side in my original triangle. I just have to do this piece first to find that D to I length, and then I can be able to use that. I'll be able to use that length to find my angle. So I'm just going to use the Pythagorean theorem here to find that length of x. All right, so using Pythagorean theorem, finding that x, I got it to be the square root of 11.25. I caution against rounding this right now just because it's not our final answer. So I'm going to use that 11.25 in the original triangle that I had brought out, the DIH triangle. So now I have enough information to use either sine, cosine, or tangent to find that missing angle. So I have the opposite, I had that 12, and I now have the adjacent. Opposite and adjacent means tangent. So I'm looking for the tangent of theta, and it's going to be the opposite, which is 12, divided by the adjacent, which is that 11.25. Remember, when you're looking for an angle, you need to use the inverse trig function. So I'll use the inverse tangent of 12 divided by root 11.25. And then I'll put that into Desmos or my calculator, remembering that I have to be in degree mode. And I get rounded to 3 significant figures, 77.8 degrees. So it's really just about looking at the diagram, pulling out pieces that you need. Don't be distracted by, all of the different things that's going on in the triangle. All right, part B, we're looking for the length G to I. So we're looking for this length. So thinking about the pieces that I have, looking at, the DIG, that's not really going to help me much. I just know that that's where this artwork is going to be placed. But I do notice that I easily can use this I to H, like we just did. I can also go ahead and make a right triangle. That's really your goal with this, is to always try to make a right angle somewhere, because you can only use SOHCAHTOA with right angles. So your goal with these is to find right triangles so that you can use it. So I'm going to bring out that triangle GHI into 2D over here. All right, so focusing on that GHI triangle, I already know that I to H is 12 centimeters because I know it's the height. Then the tricky part is remembering back to geometry. So this base, remember, is an equilateral triangle. So that means A to B is 3 centimeters. We also know from the given information at the top that both G and H are midpoints of A to B and B to C, respectively. So what that means is that this little triangle on the bottom here, GHB, that triangle is similar to the triangle ABC, which just means that if I know G to B is 1.5, because again, G is a midpoint, I know B to H is 1.5 because again, H is a midpoint. That means that G to H has to also be 1.5. We can assume that just because G and H are both midpoints. And we already knew that ABC, that big triangle on the bottom, was an equilateral triangle. So that's why we can assume that G to H is 1.5. And now we're looking for the length G to I, which I'll just call X. So now that we've pulled that triangle out, that's the hard part. Now we just have to do Pythagorean theorem to figure out X. So finding that hypotenuse, I'm looking at 1.5 squared plus 12 squared. So about 12.093, but rounded to 3 sig figs, we're looking at 12.1 centimeters for G to I. All right, so finally, in part C, we're looking for the length of D to G. So we're looking for this length. So again, just picking out a right triangle, that's all you're looking for. So if I'm using D to G, then I can easily know that, again, a height with the base will make a right angle. So if I look at D to A to G, that will form the right angle that I can use to find D to G, to find this hypotenuse. So again, let me take that triangle out into 2D. All right, so looking at my DAG, I know that the height D to A is 12. I also know like I've said a few times, that G is the midpoint. So that means A to G is 1.5. So I know that this height is 12, this length is 1.5, and we're again looking for the hypotenuse there. So it's really the same work that we did in part B, it's just we're looking for a different hypotenuse. But it'll look the same in terms of work and the same answer. All right, so again, finding that hypotenuse using Pythagorean theorem, we end up still getting 12.1 because it was the same numbers, just in a different triangle. So to kind of sum up number one in a nutshell is just look for right triangles. Anytime you're using SOHCAHTOA or you want to use Pythagorean theorem, you have to have a right triangle. So try to pick out right triangles from the given problem. All right, number two, a solid metal cylinder has the following dimensions given to us here. The cylinder is melted down into 2 centimeter cubes, and how many cubes can be made? So one thing to note, how many cubes can be made, we need a whole number here as our answer. Just because we can't make, a fraction of a cube. I mean, we can, but they're asking for how many cubes. What is also very important to note is that this centimeters is not cubed, which means the volume of the cubes that they're talking about is not 2 centimeters cubed. They're saying that these cubes have dimensions of 2. So the cubes, remember, cubes have the same length, width, and height. So all of those dimensions are 2 centimeters. That's what they're talking about when it's not cubed itself. So the volume that we're looking at for these cubes is length times width times height. So 2 cubed or 8. So the volume of the cubes is 8. So what we're going to have to do also is figure out what is the volume of this cylinder in order to figure out how many of these 8 cubic centimeters we can make. So figuring out the volume of a cylinder, we can look to our formula booklet to figure out the formula to use. And it is pi r squared h, which is basically just the circle times the height. So pi times my radius squared times the height. Oops. And I get about, remember not rounding too much prematurely, I get about 273.444, et cetera. So I'm going to take that 273 and change, and I'm going to divide it by the 8 that we had gotten before for the cubes. So 273.4. Again, not rounding. If you're doing this in your calculator or in Desmos, just use the answer they gave you so you don't round prematurely. But we're dividing that by the volume of the cubes, which we had found first to be 8. And doing that, I get 34.180. But remember, we want whole number of cubes. How many whole cubes can we make from this? We can make 34 whole cubes. All right, number 3, an ice cream cone consists of a circular cone on the bottom with a hemisphere of ice cream on top, and they're joined at their circular face. The hemisphere has a radius of 4 as indicated on the diagram, and the cone's perpendicular height is 9 centimeters, meaning its true height versus its slant height is 9 centimeters. We're finding the total volume of the ice cream and its cone, giving our answers in terms of pi, which just means leave pi in your answer. Don't sub in 3.14, et cetera. You're leaving pi in your answer. So we're going to have to find 2 different volumes here. We're going to find the volume of the ice cream and the volume of the cone. And then we'll just add them together. So my volume of the ice cream, I'm going to take the volume of the sphere, which I can find in my formula booklet, but I'm going to cut it in half since they told us it's a hemisphere. So I'm going to do half of the volume formula, which from the formula booklet says it's 4/3 pi r cubed. I'm going to sub in everything I know and get my answer. For my cone, looking at the volume of a right cone in the formula booklet, right as in 90 degree, not correct. The volume formula is 1/3 pi r squared h, meaning the height. So I'll plug in what I know for both of them. I'm going to leave pi in my answer. When I evaluate these, I'm going to leave that pi in my answer instead of evaluating the total volume with it multiplied in. All right, so subbing in what I know, I'm going to focus on ice cream first. I went ahead and simplified 1/2 times 4/3. You don't have to, but I just went ahead and simplified that with subbing in my radius. And what I would do to evaluate this, if you're ever not sure how to work with this, just ignore the pi for a second and do 2/3 times 4 cubed in your calculator and let it, and change it to a fraction, just because of that third in the denominator. If it doesn't divide evenly, it's going to give you a super weird decimal. So if I do that in my calculator and I change it to a fraction, I get 1/28/3. And then I'll just stick the pi with it at the end, or in the numerator, but not in the denominator. So either like this or 1/28 pi divided by 3. Those are your two options. Same kind of deal with the cone. You can ignore the pi for a second and just work with the numbers. And I'll get, this one does divide evenly, the 3 divides evenly. I get 48 pi. So step 3, I'm just going to add them together to get my total. I'll do my 1/28 pi over 3 plus my 48 pi. Again, if you're not sure how to work this, just ignore the pi's. You know it's going to be in your answer, and just add 1/28/3 plus 48, and I get 272 divided by 3 pi, or 272 pi over 3. And that's our final answer for part A. All right, letter B. We're focusing now on the surface area, the total surface area of the whole cone, giving our answers to 3 significant figures this time. So this time we don't have to worry about leaving the pi's in there at all. But same kind of idea, except instead of focusing on volume, we're looking at surface area. All right, so for my ice cream, again, we're only looking at half of the surface area of the sphere formula. So half of the formula from my formula booklet is 4 pi r squared. And I'll sub in what I know and get my answer. My cone, I'm going to need the formula for the curved surface of the cone, which is pi r L. So that L, remember, represents the slant length. So what I'm going to have to do in order to find it, let me go back up to my diagram, is I'm going to need to find this slant length. So again, you're always looking for right angles. We have a right triangle here. So I have this height of 9, I have the length of 4, and I can use that in the Pythagorean theorem to find this slant length. I'm going to call it L since that's what it is in the formula. So using Pythagorean theorem, I end up getting, again, trying to not round too prematurely, I get that L is the square root of 97. So that's what I'm going to use in the formula for my cone, is that slant length of the square root of 97. So let me plug everything in and work out my solutions for these two. All right, so subbing in what I know and plugging them into your calculator. Remembering the final answer should be rounded to 3 sig figs. So these ones I'm going to keep a few extra figs here just to make sure I don't round early and then end up messing up my final answers. So my ice cream surface area is around 100.5309. My surface area of my cone is around 123.7643. Do some ellipses to indicate that they do go on for longer than that, but that's just what I'm using here. And my total, I'm just going to add those two together. And I'm getting 224.295, but to three significant figures, just 224 centimeters squared, because I'm looking at surface area. I should have added with the answer to the first one, centimeters cubed. Just add it in. All right, number 4 is our last 3D figure. So number 4, we have this cuboid, which means it's basically a prism. It does not mean it's a cube. It just means prism. And it has all these vertices with their coordinates shown in the diagram. So everything's labeled. Remember, X comes out towards you, Y goes out to the right, and Z is going straight up. And that's the order that these ordered pairs go in as well, or these coordinates go in as well. X and then Y and then Z. We're first asked to find the total surface area of the cuboid. So remember, prisms in general, they have similar sides in the sense that I can find, let's say, the top of this cuboid, I can find the area of the top, and it'll be the same as the area on the bottom. So I'm going to find surface area of the top and bottom. I can also find the surface area of the front piece, FPBA, and it'll be the same as the back piece, EOCD. So front and back. Finally, I can find the left piece, FEOA, and it'll be the same as the right piece, PDCB. This right piece, they'll be the same, so left and right. All right, so let's now actually find them. For all of them, first of all, I'm going to have 2 times whatever area I'm about to find, since again, you're finding 2 panels of the whole prism itself, or the whole cuboid. So 2 times whatever the area is. And then I'll just add up all these totals. So looking at top and bottom first. So this top piece might be, I don't know if it's easier for you to look at top piece or bottom piece, but I'm looking at maybe the bottom. I'm looking at a length or an X value of 3, and I can tell that from the A just because it's easiest because it's on the X axis. And it has a width of 5 based on the Y value. So I'm doing 3 times 5 or 5 times 3. Looking at the front piece or the back piece, front might be easier. Front has, again, the same length as the Y value that we just talked about. So this front piece has a length of 5. Oops. It also has a height of whatever the Z value is. So if I go up along A to F, that Z value is 6. So the height is 6. So I'm looking at 5 times 6 for my front and back pieces. And then finally, the left and right pieces. I'm just going to use this left piece because I already have the 2 sides that I need. My width or my X value is that 3, and my height or the Z value is that 6. So 3 times 6. So working all 3 of those out and then adding them together will get me my total surface area, which should be, I get 30, 60, and then 36. So 126. They don't give us any units here, so you could just leave it as 126 or 126 units squared. All right, next up, they're asking us to find the length of the diagonal. Length meaning distance. So now there's lots of different options that you can go But there's lots of different options you can use to find that distance of the diagonal or the length of the diagonal. I'm going to list them out and then I'm going to explain which one I'm going to use because it's going to be the easiest one. So option one would be go from E at the top down to B at the bottom. So going from top back to bottom front. Keeping along that back piece, I can go from O to P. So that'll be another, you're basically just going from a corner to a corner. One corner to the opposite corner, I should say. I could also do from A back to D. Or I could do F across to C. Any one of those three you can do. What, in my opinion, would be the easiest would be from O to P. And the reason it's going to be the easiest is if you look at O's coordinates, they're straight zeros. So in terms of just if you wanted to do mental math, it's going to be the easiest to use because you're subtracting zero a lot. So you can use any one of the three, it won't matter, but I just suggest doing O to P because then you don't have to worry about a second coordinate. So I'll use the triple zeros and then I'll use the 3, 5, 6, and I'm using my distance formula for this. All right, so subbing into my distance formula for 3 points, you're really just taking the difference between each of the coordinates and squaring them, and then adding all three differences squared together. So I'm getting 8.366, etc., or to three significant figures, 8.37. Again, just units or just 8.37 is fine since they didn't give us any units. Part C in general says the diagonals AD and BE intersect at the point M. So AB, sketch these in here, keyword being sketch. AD, sorry, I don't know what I just said. A to D and B to E intersect at point M, so right in the middle here. Whereas to first find the coordinates of M. So in general, if you're going to cross diagonals in a cuboid or in a prism, that point, and they labeled it M for a reason, that point is your midpoint of the points that you're looking at. So either, in this case, of the midpoints of A to D and B to E. So I'm just looking for the midpoint of the entire cuboid. So now remember, midpoint we've talked about before that you're really just finding the average of points. You do not have to find the average of 3 different points here. You're really just looking at either the midpoint from A to D or the midpoint from B to E. It's going to be the same point either way you look at it. So I'm going from, or I'm finding, I'm going to look at A to D. I'm looking at the midpoint between 3 and 0. So halfway between those two would be 1.5. I'm looking at, I should be writing this, sorry. I'm also looking at the midpoint between those are routine my x's, my midpoint between my y's, 0 and 5. Halfway between that would be 2.5. And the midpoint between my z's, 0 and 3 would be, or sorry, 0 and 6 would be 3. And finally, part 2 of this, we're finding angle AMB. So A to that midpoint M and B. So we're focusing on this triangle, but finding this angle. So again, let me bring that out into 2D so we can see it a little more clearly. All right, so this is the triangle we're looking at. So this is actually gonna be the first time where we couldn't find a right triangle to help us find this angle M up here. But we can make one out of this. So let's talk about how to make one. What we do know is A to B, remember, is the y distance or the length of this cuboid, so that's 5. We also know that A all the way up to D we found in part B, and I accidentally erased all my work. But in part B, we got this to be 8.37 as that total distance from A to D. So if M, we figured out in part CI or C1, if M is the midpoint, that means that A to M is half of the distance of what we got for the whole diagonal. So A to M is 8.37 divided by 2, whatever that is. We can figure that out in the calculator. And also this side, it depends on which side you want to use. I was automatically going for A to M, but you could also use M to B. But my point is that means that if they are the same, since they're an isosceles triangle, or this makes an isosceles triangle, I can cut that triangle in half and I'll have my right angle. That means that this small distance, I'm only looking at half of that 5, which means it's only 2.5. So let me make yet another triangle just to refocus what we're looking at. AM, and I'm not even going to label that one, but we know that's our halfway point here. So this distance is 2.5. This distance is that 8.37 over 2, which I'm just going to leave, but you can obviously work out in your calculator. And what we're going to do is we're going to use this information to find this angle. Note that's only going to be half of the angle M that we're looking for, but then we can just easily double it and be good to go. So focusing on this angle, I'll call theta for now. I am looking at my opposite and my hypotenuse. So opposite and hypotenuse means sine of angle theta equaling the opposite over the hypotenuse. And that is, I might as well just work it out so I don't have fractions within fractions, 4.185. So again, using the inverse sine to find my angle. Oh, sorry, that looked a little crazy. OMG. There we go. So using Desmos or my calculator, making sure I'm in degree mode, my angle should be around 36.681, etc. degrees. Again, not rounding it, that's on my final answer. My final answer is I'm going to take that, just so I have a little more space, I'm going to take that and I'm going to double it in order to find the entire angle M. So my 36.681 times 2 gets me my final, almost final answer, 73.3637. I only say almost final because rounding to 3 sig figs, I get 73.4 degrees for that angle AMB. All right, finally, question number 5, getting more into right triangle trig, but away from 3 dimensions. Josie is lying on top of a vertical sea cliff that is 50 meters high. She can see her mother in a kayak on the sea. The angle of depression from Josie to her mother is 40 degrees. So let's highlight things. Vertical sea cliff is 50 meters high. Angle of depression is 40 degrees. And we're trying to find the distance between the kayak and the base of the cliff. So let's draw a picture. We don't know what the heck is going on here. At least I don't without drawing a picture. So we got Josie chilling, she's laying down. They were key to say that. So that means she's, chilling on top of this cliff. That cliff is 50 meters high. Mom is out to sea and in a kayak. So mom's over here. So let's say that this is, label some things. This is Josie. This is mom. And Josie's looking at mom. We're going to assume for all intents and purposes that the cliff and the sea meet at a right angle. They also give us the angle of depression from Josie to her mother is 40 degrees. Remember, angle of depression has to come from a horizontal and go down, or it can go the other way as well, but it just has to go down from the horizontal line. So if you notice here, from Josie's line of sight, she's looking at an angle of depression, meaning out from or from a horizontal line, it's going down, or her sight line is going down 40 degrees. What we're first looking for is the distance between the kayak, mom, and the base of the cliff. So we're first looking for this distance. So thinking about, what all we have here is we're looking for this side, obviously. We have this side of 50 meters, and we're given this angle, but it's not within the triangle. So you can do one of two things. You can think back to geometry for either complementary angles, this angle inside of the triangle and the angle outside of the triangle, because of the horizontal and vertical nature, they add up to 90 degrees. So I can use that fact to say that this angle is 50 degrees. I can also say, again, geometry, this horizontal line that I drew in and the C, which we're assuming is horizontal, because they're parallel and we have this line going through them, that means the angle of 40 degrees and this angle down at mom are alternate interior angles, which means that they're the same. So either way, you don't have to bring in both. It's just really whatever one you see. So I'll do both in terms of depending on which angle you used, I'll show you how to use both. And I'm going to start with the 50 degrees just because that's what I did first. So if I'm focusing on my 50 degrees, I'm going to change color here. If I'm focusing on my 50 degrees up here, I am looking for my opposite and I have my adjacent. So that means tangent. So I'm looking at the tangent of that 50 degrees equals my opposite, which is x, divided by my adjacent, which is 50. We talked a lot about setting up a proportion and cross multiplying. So x is 50 times the tangent of 50, which means it's about, rounding to 3 sig figs, 59.6 meters. So that's option 1, if you're choosing to use the 50 degrees. Option 2, if you're choosing to use the 40 degrees, I am given my opposite and I am looking for my adjacent. So I'll still use tangent, but now of 40 degrees, and it's going to equal my 50, which is my opposite, divided by my adjacent, which is the x. So again, making a proportion and cross multiplying. This time though, I'll have to divide both sides by the tangent of 40. So in my calculator or in Desmos, I'll be entering 50 divided by the tan of 40. I'll still get 59.6. Again, it's just a matter of which one did you prefer to use. You still get the same answer either way, but just whichever one sticks out to you more, the 50 or the 40. Part B, Josie's father is in a hang glider 100 meters directly above Josie. You're finding the angle of depression from the hang glider to the kayak. So let me draw a picture. All right, so I went ahead and started with the information I already knew. I just took out the stuff that we used in part A. So I still have Josie on that 50-meter cliff with mom hanging out in the ocean. I'll also put in the distance between the kayak and the cliff that we had found in part A, so that 59.6 meters. Josie's father is hanging up right above Josie, so I'm going to say father. And he is 100 meters directly above Josie. So this red distance is 100 meters. We are looking for the angle of depression from the hang glider down towards the kayak. So his line of sight is here, right? That line I just drew in, but again, angle of depression has to come from a horizontal line. So this is the angle we're looking at. The issue with looking at that angle, and let me actually just highlight the whole triangle in red. So this is our giant triangle that we're now looking at. So the issue with finding this angle is it's not within that red triangle that I just drew in. However, thank you, geometry, I can find, just like how we were talking about up here with the 50 degrees, I can find this angle, I'll call phi for now, and use the fact that they're complementary angles to be able to find theta. So again, let me redraw just because what's going on here. All right, so a little cleaned up. What I did not put in yet is this height from the sea itself to data in the hang gliders. So they told us the original height from sea to Josie was 50, and then the hang glider is 100 meters above that. So this total height is 150. And again, we're going to try to find phi first and then deal with the angle of depression that we're actually asked to find. So phi itself, if I'm focusing on that, I can look at the opposite and the adjacent. So again, tangent of phi equals my opposite divided by my adjacent. Using inverse tangent, since I'm looking for an angle this time. Again, in degree mode, I'm getting phi to be around 21.6695. And then finally, to find angle theta on the outside here, again, we know that these two angles are complementary. They add up to 90 degrees. So I can find theta by doing 90 minus that 21.6695 I just got, which means it is, rounding to 3 sig figs, 68.3 degrees. You could have also, one more thing, very similar to what we were talking about up here, either using the 50 or using the 40. You could have also, again, noted that theta and this angle M down here are alternate interior angles. So you could have found angle M using 150 as your opposite and 59.6 as your adjacent, still using tangent, and then you wouldn't have had to subtract anything from 90 degrees because it would have given you that same angle measurement. So that's just another way you could have done it.